Good morning. Good morning. Welcome to the second day of the lightning sessions. Thank you for being here. I would like to ask all the authors that have a lightning talk between 9 and 10 to line up on the left side. I know even if you're late in the hour, because not all of you are here, we will start and line you up already with my colleagues on the left side of the podium. So if you have a lightning talk between 9 and 10, please already go to the left side. So we will start in a minute, but I just want to tell you or remind you a couple of things. Right now, there is the poster session from the last lightning talk of yesterday that are on the touchscreen in the room. Your posters will be on display at 10 sharp. So even if we finish early with the lightning talk, don't worry, your posters will come on the assigned board at 10, between 10 and 11, automatically. So this is organized, and you just have to find your board. I also want to remind all of you, and if you want to inform the others, you can vote for posters. So you can vote by using the app, by visiting the contribution, but you can also use the scanner in the app. You can see in the app there is a scanner button, and you can scan the QR code that are on the e-posters. So please vote. If you win, there will be the award ceremony on Friday, so I invite you to vote for the posters you prefer. And there will be multiple awards for e-posters. So I think with this, we will start with the first speaker of the morning. So have a good morning. Thank you.
Thank you. Yeah, perfect. So good morning from my side as well. So noise is a nuisance, and we want to get rid of noise, but at what cost? And to answer that, we test the new field of autoencoder-decoder machine learning-based networks to estimate what happens when you denoise seismic data and also hydroacoustic data. So can you still use the hydroacoustic and seismic data to perform follow-up analysis like moment tensor analysis? And for this purpose, we train actually an autoencoder-decoder network specifically on IMS data, which are for the region of DPRK, and then apply that to moment tensor inversions of the 2006 and 2017 DPRK tests. And we find that actually there's a great possibility to use this technology in the IMS framework, but also there has to be taken care because the current technology of denoising introduces a slight bias. So if you're interested in the IMS data set we used and the machine learning framework or the moment tensors we estimate, please see me at board 1.
Good morning, everyone. My name is John Condon from the UK NDC at AWE Blacknest. My poster today is talking about a piece of work we've done recreating the IDC's automated surface wave processing. And we've run a study for 2022 looking at whether there are any misassociations. We've found 27 misassociated surface waves within the year of 2022. And we believe this is due to a 100-degree distance limit that is being placed on the surface wave processing. We've also looked at the back azimuth residual between these misassociated surface waves and the reassociated event, and found that the back azimuth residual is reduced, giving us more confidence that they were misassociated. My poster is at board 2, so if you have more questions and would like to talk about this, please come find me. Thank you very much.
Good morning, everybody. Harry Miley, this one is for you. And the next one also, because Harry reminds the community that we should not only be considered take care of radioxenon background in the atmosphere to understand what IMS observations we make, but also radioiodine. So this poster is about the emissions of nuclear reactors, power plants, of radioiodine, and we're not only looking at the radioiodine 3 isotope plot that you see here, where surprisingly most of the entries, and there are only a few, but most of them are in the nuclear test domain. So I think we should be concerned and need to better understand. But we also look into the ratio of radioxenon to radioiodine for the same reactor releases, annual releases actually, that are reported. I can continue with the next poster, because this is now looking at IMS observations of iodine. And at some stations, these observations are quite frequent and sometimes coincide with a co-located radio xenon noble gas detector, and there are radio xenon observations at the same time. And Harry asked the question some time ago, maybe we can use the ratio of this xenon precursor to xenon to tell us something. So this poster will look into this in depth. We are looking at reactor curves of normal operation of the ratio of these two isotopes. And I pick here, for example, the ratio not of one mass chain, we also want to look into that, but those isotopes that occur most frequently, xenon 133 over iodine 131. And you see on this scatter plot, on this for isotope plot, two isotope plot over time actually, it shows how a nuclear weapon test ratio would develop. It shows you how the reactor releases would look like, and it shows you what the reported nuclear power plant releases look like in comparison to what we measure at the IMS systems. So join us at this poster and the previous one, and happy to discuss with you. Thank you very much.
Thank you, Peter. Good morning. Hello, my name is Tom Vandermark from the Air Force Technical Applications Center in the United States. Our poster today will be discussing a set of anomalous seismic events that took place in the Chhattisgarh province of India from 2018 to 2022. These events were of interest at first because of their lack of surface wave energy, screening them as possible explosion, and also based on their magnitude, they would have roughly been equivalent to a 1 kiloton underground nuclear test. So to see if these were actually events of concern, we did a few things. We conducted correlation and clustering analysis using seismic waveforms. We also conducted INSAR analysis using data from the Sentinel satellite mission. And then we did a couple of first-order back-of-the-envelope thought experiments to see if what our hypotheses were could be correct. Then to make things more interesting, it was found that all these events took place very near to a known underground coal mine. So if you'd like more details about what we found, please stop by our poster. I think it's board number 5, I hope. Thank you very much.
Good morning, everybody. I'm Bill Junner from Los Alamos National Laboratory. Back when we really did underground nuclear tests, we also made some measurements of very low frequency electromagnetic signals on the surface. And VLF here means signals below a few tens of kilohertz. And those measurements that we made have sort of intrigued us and perplexed us ever since. We don't know what the source of those signals is, and so we've always been very curious to understand if those signals have some value for monitoring, for site transparency, etc. So recently we have conducted a set of experiments using this large pink apparatus on the right-hand side to emulate the signals coming from an underground nuclear test. We've also looked at the older equipment to see if we can understand how those data were collected, and we've also looked at the earlier data. So I think at the end of the day, we have some reasonable confidence, perhaps, that we understand the mechanism to make these low-frequency signals. And that work will be reported on poster number 9. So please come by. I'll be happy to talk about this all day. Thanks.
Good morning, everybody. My name is Anne Tipka from the CTBTO. I work with the Software Applications Unit. And as you all know, we always try to improve our processes and our results from all the IMS data we get. And the DPRK test site is one of the most important test cases we use to evaluate our software. And with our current atmospheric transport modeling pipeline, we are very good in identifying DPRK from the IMS measurements we got, for example, from 2013. But as you can see here on the right panel, the test site and also the IMS station in Japan is on a very complex mountainous terrain. And we can miss a lot of small-scale meteorological features in there. So we try to improve our results by using high-resolution atmospheric transport modeling to resolve these small-scale features. And as you can see on the left side, this is a result we produced from combining 3 level C samples from 2013 and already have a very good result in identifying DPRK as the possible source region. But we use high resolution to improve this any further, and I don't want to miss your surprise to see the results and come to my poster at board number 10, I think. Thank you.
Hello, my name is Brent Delbridge from Los Alamos National Laboratory, and I'm going to be looking at methods to get yields from nuclear explosions. Particularly, we're going to take advantage of events which have multiple events in the same region to cancel out parts of the waveform that we aren't interested in. And so what I mean by transportable is we don't need to calibrate stations and/or regions using known yields. You can just take the waveforms and use relationships using the low frequency asymptotes, the corner frequency, and the high frequency asymptotes, and how those scale with yields. For earthquakes, this is difficult, but for explosions, we actually have good physical relationships which relate the two. And we take advantage of that and show that you can use that to get yields and depths of burial at the DPRK test site. And more importantly, we can also quantify how well we can do that. And if you're interested, I'm at board 11. Thank you.
Hello, my name is Josh Kunkel from the CTBTO. I've been working with many of my colleagues in IDCSA on developing an expert technical analysis tool for analyzing isotopic ratios. And we've been developing this tool, but we also want to see if we can have some automatic processes that do some of the steps and prepare results for experts. So I show here an example of station RN63, where we've looked at sequential samples, and we're identifying seeds that have at least 2 level C samples, making sequences out of these and making them, removing overlap. And then what we can do additionally is we can use the atmospheric transport modeling simulation to see if different stations should be related so that we can put them together. And then you see in the bottom figure that you can check for decay consistency of the associated samples, and at that point we can save these results for further review, and then we're going to continue expanding our work for the automatic analysis. Thank you.
Hello everyone, my name is Zhao Yungang, and I'm from Beijing Radionuclide Laboratory, China. And the problem of discriminating radiothermia derived from an explosion or anthropogenic sources is quite interesting and remains unresolved. Here I established the novel radiothermia event classification method based on chatbot machine learning algorithm. The background plus explosion signals were synthesized and modeled artificially. Based on the artificial monitoring data features were generated, such as the abnormal threshold ratios. The dataset is divided into trained datasets and validation datasets. Models were trained based on different algorithms and evaluated based on validation datasets. Here I use 11 machine learning algorithms and 5 metrics. If you want to know more, come to see my poster. Thank you.
Good morning, everyone. I am Sharif Ali. I'm lead analyst at CTBTO, International Data Center. Last 2 days, you heard, you probably heard about CEST events, RAB bulletin, automatic processing of IMS data, interactive SHI data analysis, global association algorithm, and NetVisa. interactive analysis. So if you want to hear more about these topics, and if you want to know about the impact of NetVisa in the RB since 2018, please join my poster at board 14. Thank you so much.
Good morning. I'm Won Young Kim, and about late 1980s, scientists at NOSA, Norway, has discovered that RMS LG amplitudes from underground nuclear testing and practice test site will very well correlate with body wave magnitude. Same thing for other stations, so it's called RMS LG stability. The same methodology we are using for North Korean underground nuclear test recorded at stations in Northeast Asia, some about 10 stations. And here the question is how to get network stability and be able to correlate with the yield of underground nuclear tests in North Korea. Thank you.
So, hello everyone. My name is Bo Xu Liu. I'm from the CTBTO IDC. I work as a radionuclide officer. Here I have two e-posters. Both are focused on the characterization of CTBT relevant nuclear events. In this analysis, we use the isotope ratio. So we need to combine the two sides. One is from the release, the source side. The other is the detection at the RMS station. In this poster, we focus on the source term. Yeah, currently we are working on some kind of the source term based on the Bittman equation, which is developed by the Martin Karlowski 20 years ago. Yeah, in this new development, it's developed by the Livermore laboratory, the Yongwei and Charles. So we want to get a new realistic model, include some kind of meltdown after the nuclear explosion in the cavity, and also seepage and the rain out the source, some kind of the physical process to get a more realistic estimate for the release source. Yeah. Can you come to the next one? So in this poster, we focus on the measurement and the RMS station side. We try to use the 4 Zealand plots. So generally, we observe the contribution from the nuclear facility release. But sometimes there is some kind of event from the nuclear explosion. So in this study, we get 3 signals. One is general routine observation of the, we call it radiation background at the station. The second one is we use the ATM simulation to create the nuclear signal from the underground nuclear explosion. And third one is a synthetic signal. We put the nuclear signal on top of the RMS background. So we want to see what's the impacts by adding this nuclear signal. You can see that 2 figures. Yeah, for different situations, the measurement point will from the left side is a nuclear facility domain. Move to the right side is a nuclear explosion domain. So we want to compare how much of the nuclear signal can be identified by these 4 Zealand figures, plots. Please come by the e-poster for more details. Thank you.
Well, good morning, everybody. My name is Rodrigo Chi from the University of California, Berkeley. And today I'm going to present my work that I've been working during my PhD, that I've been developing a joint inversion using waveform, first motion polarities, and also ground deformation for the 4th and 6th nuclear test event in North Korea. Developing finding a good moment tensor solution for those events is always a challenging problem. In this work, I developed the joint inversion that has that adds the ground deformation over the test site, where we have been able to fit, well, as you see in the figure, like the waveform, the ground deformation, in particular this for the 6th event, the horizontal deformation, and also the first motions. As you can see, like in the loom plots, like in the corner, we can also be able to reduce the uncertainty of the moment tensor solutions that allows to determine better the magnitude of the bomb and also its yields. Thank you. I will be in the board 16, so if you want to stop by. Thank you. Yeah.
Good morning, everyone. My name is Iulia Armeanu. I'm from Romanian NDC, and I'm also a master's student. And the study that I'm presenting today had 3 main objectives. So the first one was to relocate the nuclear tests provided by DPRK using local, regional, and teleseismic stations. And for that, we use stations for up to 70 degrees, most of them being part of the Romanian seismic network. The second aim of this study was to see if there were any other induced seismicity after the nuclear test. So for that, we use waveform cross-correlation processing signals. And the third one was to discriminate the nuclear test from the surrounding nuclear natural seismicity. And for that, we used spectral ratio measurements and also CODA waves analysis. So if you are interested in this study, and if you want to talk more about it, I will be at number 20. Thank you so much, and see you in an hour, because I'm from 10 to 11. Thank you.
Good morning. I'm Robert Abbott from the Sandy National Laboratories, and I'm going to be presenting on the instrumentation plan for the Rock Valley Direct Comparison Experiment. Under RVDC, we're going to do a large chemical explosion at seismogenic depth near the hypercenters of a series of shallow earthquakes that happened in Rock Valley in 1993. Thus doing, we're going to be able to compare earthquakes and explosions sharing the same propagation path, the same instrumentation, the same depth, and the same source material properties, probably for the first time ever. So please come by, and I'll go over the subsurface, the surface, and the aerial diagnostics that we plan on deploying.
Good morning, everyone. My name is Zaidin Mukambayev. I'm from Kazakhstan NDC. Today I will try to say about mining explosion in former test site, semi-platinum test site. You know, its last nuclear explosion was conducted in 1989, and now it's our test site is almost closed. But in territory of test site, we have many mining activity, and we try to use data from IMS station and non-IMS station to improve our location of this mining explosion, because in this area also have natural seismic activity, and we must know which one is natural, which one is induced seismicity. And if you have interesting about this work, please come to my poster 166, and we can try best Kazakh chocolate also. Thank you.
Good morning, everybody. My name is István Bonder, and now change of topic. I'm introducing the Central and Eastern European infrasound network, and we show that this network dramatically increases the detection capability of the infrasound network in Europe. We also produce a biannual bulletin, seismoacoustic events, but many of them are ground truth events, and we identify coherent noise sources in the region, and we show that our network bears witness of the war in Ukraine. Thank you.
Hello. So, good morning. I have a presentation about the Nord Stream explosion. I am from the Austrian NDC, so welcome to Vienna. I used the explosion as a test for our NDC to test our capabilities. So I was using software provided by the BTS, NDC in a box software, and if you're interested how you can read non-IMS station and use them, I welcome you at my poster. Thank you.
Hello everyone, my name is Antoine Turquier. I will be talking about the largest mine-induced earthquake in Sweden, happened in 2020. It happened in the north of Sweden, in a city called Kiruna, and then we analyzed the data that's consisting seismic and infrasonic components. It is unique because both of them had near field and far field components that we received. We continued exploiting the data afterwards with near field and far field simulations with an objective to understand how much infrasound can contribute to understanding source mechanisms and focal depth. If you want to hear more about it, I'll be at the screen 30 starting from 10. Thank you.
Hey, good morning, everyone. My name is Patrick Hupe. I'm from BGR in Germany, and my e-poster is about open access data products derived from infrasound detection lists processed at BGR. We know that infrasound detections are well correlated with the atmospheric dynamics, so our intention was to make infrasound data of the IMS available to a broader community. And yeah, this e-poster highlights recent updates of the published products, and we show some examples of recent events. And yeah, if you have any questions about how to download the data or face any issues with the download, please find me at poster board number 31. Thank you.
Good morning. My name is Daniela Ghica. I'm from Romanian NDC, and my poster is about a collection of infrasound observation, which I observed with the Romanian infrasound stations. I used as sources for events bulletins from IDC and other international agencies. Basically, the collection contains information on the detections and detection plots. So if you are interested, I can tell you more in my poster. Thank you.
Good morning. My name is Christoph Pilger. I'm from BGR in Germany. And this is a study about the systematic analysis of IMS raw data of hydrophones to characterize sources. And we used a machine learning-based denoiser approach that was also presented in the first lightning talk of this morning. And we applied it on hydrophone data with the aim to identify special events like the DPRK 6th nuclear test and like other earthquake events. And it's kind of proof of concept that we were able to improve the signal-to-noise ratio and were able to transfer this denoiser, although it was trained on something a little different. So our main conclusion is if we specialize the training to remove selected noise sources or to identify selected events of interest, it would even be more prominent to apply it on IMS data. If you are interested to see more, please come to poster board 34. Thank you. Thank you.
Thank you. Hello, I'm Mikhail Roshko from ISTI, United States. And today's presentation is mostly about the status of the PowerMT development, upgrading, testing, and tuning. PowerMT is a part of the expert technical analysis software suite for SHI, and intended for simultaneous determination of the depth, magnitude, and focal mechanism for most of the seismic sources. It has powerful user interface. It's integrated lots of public domain software, application software, including pre-computed synthetic software for global models, for most of the global models. We consider it as a pretty good tool for facilitated PTS commissioning by providing additional screening tool for IDC analysts and fusion officer. So for more information, please come to our station number 35. Thank you.
Morning. My name is Kwasi Benjamin from Côte d'Ivoire, NDC. My poster is about the localization of regional infrastructure sources over West Africa. And in 2018, PTS and Côte d'Ivoire NDC are deployed for 1 year a portable infrastructure array in the northeast of Ivory Coast. And we find with the both infrastructure portable array and IS-17, the local regional infrastructure sources such as mining in Mali, Ghana, and Ivory Coast. We also investigated with the portable array infrastructure data, the splitting characteristic of the mesoscale convective system over West Africa. I invite everybody here to come to see my poster and discuss with me in the aim to improve this work. Thank you very much.
Hi, everybody. My name is Arben Pitarka from Lawrence Livermore National Lab in the United States. This poster is mostly focused on using high-performance computing to analyze the performance of P2S discriminant that is very popular in discriminating seismic sources. What we wanted to investigate is the possibility of understanding the effect of the radiation pattern and the wave propagation effect in this P2S ratio, which involves signatures of the seismic waveforms. And for that, we focus on the third phase of the SPI experiment, where we developed a velocity model that includes deterministic and stochastic components. The idea is to go to very high frequencies to understand the wave propagation effect. What we found is that the effect of the wave scattering is strong at any distance, but there is hope that depending on the geological structure, if we use an average on a dense network or a good coverage with station, we can still use efficiently this very important discriminant at local or regional distances. So if you're interested in understanding what we have been doing and what is our plan for the future, please stop by my poster. Thank you.
Hi, I'm Jonas Kintner at Los Alamos. This is some actual work that we did looking at some historical nuclear tests in Central Asia, specifically the Lopnor test site. Oops, I actually spelled site wrong. Excuse me for that. And we're actually specifically looking at how the election of a different velocity models affects our answers. So I'm happy to discuss this more. I'm at poster board number 38. So thank you.
Hello, everyone. I'm thrilled to be here today to present a poster about the infrasound reference event database and the crucial necessity for its revision. Established in 2010, the infrasound reference event database was designed to gather, review, and document infrasound events that are particularly noteworthy. The purpose of this poster is to highlight the significance of revisiting this database and evaluating its overall relevance and accuracy. By conducting a comprehensive assessment, we can ensure that the database remains a reliable and up-to-date resource. I invite you all to explore the details of this important work at board number 39. I'm Abdulwahab Agarbi from Tunisia.
Hello, good morning, everyone. My name is SnT2023. Here I'm presenting the results of looking at the mining explosion events and using the case for I-35 and I-47. So in this situation, we improved the location of events that were in the past only using seismic data. But in this work, we are using both seismic and infrasound data and using the NDC in a box package. And by combining the two results, we have improved the location of and the accuracy of those mine explosions. And in this case, both stations, I-35 and I-47, have increased the accuracy of the results. So if you want to know more about the analysis, the software used, and the method used, you can visit my poster number 40. Thank you.
Good morning, everyone. My name is Atalia Yele from Ethiopia. I have poster number board 41, and our region is dominated by volcanic swarms, and we have a serious problem of phase peaking because it's an active rift and it's a ductile zone. So this is just a poster to initiate a discussion with some CTBTO people if we can really use RSTT code and develop a 1D model. And we have a serious problem in our region for locating earthquakes. So this is just to open up discussion with the experts at CTBTO. So the one on the left panel is showing that Afar is really dominated by volcanic swarms, and if we can use those well-located volcanic events as a ground truth events and generate a reasonable crystal structure for locating earthquakes. So that's the whole point. So my poster is board number 41. If you have any advice or whatever, please come and visit my poster. Thank you.
Hello, everybody. My name is Darlan Fontinelli. I'm from University of Brasilia. I would like to invite you to visit our e-post number 42 about a study that proposes a practical method that use collocated sensors, one seismic station, one seismic sensor, and one infrasonic sensor, to help you distinguish between tectonic events from quarry blasts. Thank you.
Hello, my name is David Applebaum. I'm with the analyst team here at the CTBTO. I guess not here, but like there, more or less. And I want to talk to you a little bit about some recent things that we've done with the infrasound analysis in the IDC. We've added some stations, and those have allowed us to see some events or to build events in our bulletin products that previously could not have been built or that could have been built with less precise locations. And also, we'll go over a little bit some of the trends in the infrasound bulletins over the last several years. The summary is more stations, more events. So not too many surprises there. But if you'd like to talk to me more about these different events that we could see, which included a recent volcanic event and the James Webb Space Telescope launch, you can, or anything else related to infrasound analysis at the IDC, feel free to see me at my poster, number 43.
Good morning, everyone. I'm presenting on behalf of a large group of authors. I would tell you about what we have found out from the Nord Stream gas explosions. On the 26th of September, several large gas bubbles were observed in the Baltic Sea. And at the Danish NDC, we quickly realized that we had detected 2 events on the Nord Stream gas pipelines with very clear explosive signature. And in the weeks and months that followed, a team of seismologists from Denmark, Sweden, Norway, and Germany worked together on a deeper analysis of the events. And we were able to identify that the second event actually consists of 3 blasts with clear explosive signature. And we also concluded that using local data worked a lot better than, gave more precise results than using data from the IAB. So please come to poster number 44, and we will tell you the whole story of what we know.
Good morning, everyone. My name is Uche Madu. I come from the Nigerian NDC. And on the 26th of September 2020, 2 events occurred in the North Sea, in the Nord Stream. We carried out 3 things. 1, we listened. 2, we used the opportunity to evaluate the IMS. 3, we also used the opportunity to examine the robustness of the softwares that are being issued by the CTBT. And we found out 2 things. If you want to know about those 2 things and the other 2 things about life, come and visit poster number 46 and we'll talk. Or you can visit me at any time in the course of the conference. Thank you.
Thank you. Hello, welcome everybody. My name is Ronnie Quintero from Oxycori Una Institute in Costa Rica. In this case, I will present the possible GTA-5 event in Costa Rica, the importance of using local catalog. From 2010 onward, we are using Antelope and GeneLog program for locating earthquake. In this case, I convert the data to CEST formats and try to use the boundary rule for proposing GT5 events in the zone. Please, you can visit the poster 48, and I will welcome you in there. Thank you. Again, yeah, I have another poster, the 49. This is a landslide called Cambronero landslide last year. This landslide caused some dead people there. And after this problem happened there, some questions arise. We want to answer some of the questions, like there are some fault there close to the place where the landslide occurred, and that is what we want to answer in this e-poster. Also, I want to contribute with the catalog of the landslides in Costa Rica using infrasound data. In this case, I also analyzed the possible infrasound data in one of the stations very close to the landslide. Thank you. You can visit me at the 49.
Good morning. Mark Harris from Sandia Labs in the United States. For several years, we've been working with the US NDC to modernize their operational software system. We call this our new system, the Geophysical Monitoring System, or GMS. This is a work in progress. We're midway through this development, but we're building a new system that's cloud-ready, high-quality, secure, and we're releasing this as open source software for potential use by the IDC in their re-engineering program as well. So we've developed a station state of health monitoring application that's being deployed by the USNDC currently, and we're midway through redeveloping the analysis software that's used by the waveform analysts, so intended to replace the ARS, or the Analyst Review Station. So if you're interested in this, come by poster number 51. Thank you.
Thank you. Good morning. I'm Rob Mellors of the University of California, San Diego. We operate a 40-station global seismic network. 14 of these stations are auxiliary stations. And so it turns out that running a global network is expensive. And during COVID, we found we were forced to rely on local station operators for more of the work. And we found that saves considerable budget and travel budget and in field engineering budget. And the advantages are it builds capability at the local level, and it has quicker response on data repair. Some of the disadvantages is that we have to put much more effort into training and documentation, often in different languages. We pre-position spares, and it requires a very close relationship with the station operator. So if you'd like to discuss network logistics and budget, I'll be at poster number 54. Thank you.
Hello, everyone. Please bear with me, as I know we would like to forget, but please cast your mind back to 2020. Terms such as pandemic, border closures, quarantine, social distancing, virtual meetings, all became commonplace. My name is Marcus Greshnik. I'm representing my agency, the Australian Radiation Protection and Nuclear Safety Agency, based in Melbourne. We manage 9 sites for radionuclide monitoring, as you can see above me, all around Australia and the regions nearby. During this time, there were travel restrictions from Melbourne. Travel was denied, has been denied, and only actually opened up completely in May of this year. If you would like to know more about how we've maintained our data availability over this time, please join me. I'm all the way down the end in the left-hand corner. You can social distance down there as well. I'm at panel number 55. Thank you.
Good morning. My name is Diego Ortiz. I work for the CTBTO in the maintenance unit. And what we would like to show in this presentation is the type of field work that the maintenance unit performed in the IMS station. Basically, after the COVID restrictions were lifted, we were able to travel a bit more. So our maintenance that in the past was based basically on remote assistance only, start being more duty trips and works in the field where we could perform corrective actions or preventive actions or some training on the operator. All of these get to a better performance of the station, and in principle this work should continue in the near future as we still have some backlog to do. So if you want to see more about this type of operation, it's on poster 54, and I'll be waiting for you. Thank you.
All right. So, hello, good morning. I'm Paulo Cruz. I'm from the operations section of the CTBTO's International Data Center Division. So one of our key tasks is to make sure that the stations, the IMS stations, are performing to continuously to ensure that all the requirements of data availability and data quality are met in accordance to the IMS operational manuals. So for us in the regional CLIDE, monitoring network, we make sure that they are up and running. So in the PTS in operations, in the monitoring facilities operations unit, we use the radionuclide operations support system, or ROS, to monitor the state of health of our radionuclide monitoring stations and ensure that they are in top shape. So if you're interested, please come to my poster at the board 58. I will discuss to you the ROS, its functionalities, and how it helps us to identify station issues and make sure that we are performing in accordance to the treaty. Thank you.
Hello everybody, my name is Bao Maman. I'm Nuclear Instrumentation Maintenance Engineer at the Niger High Authority of Atomic Energy, HANEA. I'm here to discuss with you about the Niger experiences, like radionuclide station RN48 installation by local skills. However, France company cannot go to Agadez to install the station. HANEA national authority negotiates with CTBTO and obtain the ANVIA agreement to train us at headquarters Poissy on different topics related to the station installation and certification process. The e-poster highlights installation process, the results obtained after the initial test and certification process. Thank you for your attention.
Hello everyone, let me introduce my work, which is called Seismic Events in Central Kazakhstan by data of the National Nuclear Center Monitoring Network of the Republic of Kazakhstan. In recent decades, different nature events were recorded on this territory by the National Nuclear Center Republic of Kazakhstan Stations Network. The major part of events are mining explosions. They are also induced in nature earthquakes. The criteria of natural events appearance of seismically low active region of central Kazakhstan were studied in view of tectonics and analysis of geophysical fields. The earthquakes focal are confined to deep faults or faults cross nodes to the places of about turn stress sign and orientation of geophysical fields and anomalies. 20 mechanisms of earthquakes focal were constructed for central Kazakhstan. If you want to learn more about this, come to see my e-poster during session P2.3. Thank you very much.
In 2019, 2021, 2022, there were explosions at ammunition depots located off the territory of Kazakhstan and Uzbekistan. The explosions were recorded by Karatol Seismic Array and SnT2023 infrasound station. The energy of the largest explosion in all series was almost the same. But the event chronology and consequences were different. The seismic bulletin were made for all investigated events, indication all different parameters. If you want to learn more about this, including the event's magnitude, distance, and other parameters, come see my e-post during CEST 20.3 on the date, or access it to one on the SnT conference platform.
Thank you. Thank you very much. Thank you very much for the highlight talk. That was really interesting. So just a point of order. In a few minutes, you will hear the gong. It will just be for the e-poster presenters that are now there to know that their poster will soon be over. And at 10, there will be another gong when we are bringing up your posters to be shown on the screens. So don't be alarmed if you go now. They are not yet there, but they will be there in 4 minutes. And for this lightning talk speaker that will be in the next hour, so I ask you again, please come line up already with my colleague on the left side, and come early so that we know you're here and we know we can prepare the sequence. Thank you very much. See you in a few minutes. Hello, good morning again. So next lightning talk session, I hope we have most of the speakers that are already in the room. If you're speaking in this session, please go to my colleague on... So that was not planned, it was a bit later than planned, okay. Anyway, so if you're a speaker in this lightning talk session, please go to my colleague on the left. Even if you're speaking at the end of the session, please already go there so that we know you're here, and announce yourself to my colleagues. Just in case you were not here at 9 when I did these announcements, right now we have the e-posters on the touchscreen that are displayed from the colleagues that had lightning talks earlier. Your e-posters will be displayed at 11 sharp. So don't be alarmed if you go at a bit earlier to your board number. It will not be there yet, but it will be displayed at 11 sharp. Very good. With this, I think we will be ready to start. And the last announcement is please vote. Vote for the best posters, vote for the best overall. For the posters, you can use the app. There's a scanner button on the app, and you can scan the QR code. So, first one, let's go. Let's start.
Thank you. Oops. Hello again. I'm István Bondár, and my poster shows the collaboration between Livermore and Central Asian NDCs, Kazakhstan, Kyrgyzstan. We collected a large data set. Many of them are not reported to the ISC. And we relocated the bulletin, which contains some 200,000 events, and I will show you the results. The figure just shows the before and after picture. The after picture shows a much better result seismicity of the area. Thank you very much.
Thank you, István. Yes, so that's our poster. My name is Victoria Wanja, and I'm going to present a poster for the whole Leidos team that you see up there. We thought that there is no greater opportunity for us to present our work and also to announce that the nuclear explosion data repository called WFNE is now open for everybody. So we invite you to get access, to look at our data, to use it for your own work, and then provide some feedback. And one more request is please feel free to contribute to this data. So we'd like to enrich our repository and help the nuclear explosion monitoring community to do better work. Thank you so much.
Good morning, Hofburg, and hi to everyone watching all over the world. This is a poster on the radionuclide historic observations of nuclear tests, and I'm only focusing on those observations from remote, not at the test site, because those are most interesting to compare with IMIS monitoring system. We don't have so many nuclear tests, fortunately, to learn and get experience what the signature is and what we can expect from a nuclear test to arrive at IMIS stations. But there's a lot of material from past observations and the scientific publications on these observations. So this poster is not about the raw spectral data and digitizing and things like this. It's about publications and the isotopes reported and their concentrations. And I compare statistically counting how often were which isotopes reported, that we also have in our CTBT list of relevant nuclides. And I compared our list in our IMIS observations with historic reports. And there are also some other attempts of reducing the number of relevant nuclides down to what is significant. And I'm checking against historical data whether these significant lists make sense or are missing something. So meet me at my poster. It's poster board number 5. Thank you very much.
Hi, my name is Ryan Gallagher. I'm a developer at the International Seismological Centre. The poster I'll be presenting for the ISC today is outlining how best to get access to ISC data if you're NDC or an approved party. There is a website link that's set up between the ISC and the CTBTO, which allows you to access the ISC's data with some additional tools in a more user-friendly manner. So this is especially of interest to people that are interested in using the ground truth data spit. So that consists of many well-located natural earthquakes, but also nuclear explosion data, GT0. So the waveforms are available through the link site. They're not available on the ISC website. So that's specially available to this community. So I'll be presenting the poster. I'm happy to do demonstrations downstairs at the ISC booth if people are interested. And yeah, if you have any questions about anything on the website in particular, I'm the person to ask. So thank you.
Brian Young, Sandia National Laboratories, United States. We have digitized over 1,000 waveforms, new old waveforms from US underground nuclear tests in the 1970s and 60s. Come to my poster, it's poster 12 if you'd like to see how we did that. Those waveforms are now available for download on IRIS as of last week. Thank you.
Hello, everybody. The task of historical data preservation and digitizing is very actual for specialists in the field of seismology and geophysics. And that is why I would like in our poster to present the results of digitizing of the nuclear explosions, atmospheric explosions conducted at the Lobnor test site, as well as the earthquake occurred in this area. So please visit our poster number 190. Thank you.
Hello, everyone. My name is Ehsan Korbani Chegeni from CTBTO. Yes, that's right. As you might know, one of the most important products of the CTBTO is the event bulletins. These are the late event bulletin, LEB in short, and the reviewed event bulletin, which is the REB. So at the monitoring and data analysis section of the International Data Center, these bulletins are produced from automatic event list. Basically, the automatically created events that you see on the map on the left are transforming to carefully analyzed and refined events shown on the map on the right. So these bulletins are releasing since June 1999. This year is the 25th years of the data analysis. So in this work, I show some achievements and statistics of the data analysis over the last 25 years, as well as some challenges that we have been facing over time. So if you are interested in knowing more details of the data analysis and bulletin production, please visit this e-poster at board number 14, I guess. Thank you.
It's not this one. No, not this one. Okay. Good morning, everybody. My name is Eduardo Diez. I'm from Cuban National Center for Seismic Research. First of all, I would like to thank to CTBTO and the organizers, local organizers, to give us the opportunity to stay here and show the results of our research, which is mainly pointing to evaluation of the event detection level for our network in Cuba. Focus, which is one of the key and important data
in order to improve the seismic network around the world. As you know, probably, we focus to evaluation of the detection using signal-to-noise ratio. It means measuring effective noise level in each station and compare with the theoretical amplitudes of the signal in each station, and from this evaluate the worst, medium, and better case for detection. I want to see that this work is the result of collaboration with Italian Institute Osservatorio Geofisico Sperimentale. We have a very fruitful collaboration with this, and the result of the research is improve both the Cuban network as well as the Italian network, seismic network. This is all the results I compared with the seismic catalog for validation. And this is all. We will invite you to see our poster for better explanations. And thank you very much, and have a nice day. Thank you.
Hi, yes, so Ryan Gallagher again, developer at the ISC. The other poster I wanted to talk to you is about during this session is using some of the phases that are reported to the ISC for the IMS network. We're able to have a look at some quality control factors on the stations. So these are available through the main ISC website and through the CTBTO link site. So you can see here, as an example, I'm showing the Warramunga array, and you can see that historically there was an issue in 1995. That can be seen really clearly from the mean residuals that have been reported to the ISC. Obviously that was then corrected, but this can be checked on many FDSN stations and the IMS stations through the ISC link, the CTBTO link to the ISC website. And again, new tools that we're developing checking polarity at stations, which can tell you something about if you think there is a reverse polarity at a station. Obviously, that's highly unlikely at an IMS station, but more likely it can tell you variations in these plots can tell you things about station operation and station health. And again, if you're interested, come by the poster or come down to the ISC booth. I'm happy to give a hands-on demonstration, and we can have a look at some stations and examples. So, thank you all.
Good morning, everyone. My name is Retno Dewi from Indonesia. My poster about evaluation of accelerogram data quality system based on machine learning on seismic network in Indonesia. Earthquake strong motion data from accelerogram equipment is crucial for determining earthquake intensity and other needs in earthquake disaster mitigation. This evaluation system is designed using the result of multi-layer perceptron and k-nearest neighbor machine learning computation. The result, the evaluation system with machine learning found the KNN model has an accuracy of 91.2% better than multi-layer perceptron. If you are interested, see my poster. And thank you.
Good morning. My name is Thibaut Arnal, and I work at CTBTO as a software engineer. My poster is about the modernization of the station state of health system. And if you want to hear about the challenges and technical solution, please find me in the room next to it. Thank you very much.
Good morning. My name is Ishaq Tata. I'm working at the CTBTO, specifically at the International Data Center. The work that is presented in my e-poster aims to evaluate the performance of the IMS network, and by simulating this network and by monitoring the minimum detectable source strength over time. So this was achieved by analyzing the simulation results produced by the Java-based tool net mode that was developed at Sandia National Laboratories and was provided to the PTS as contribution in kind to be evaluated for its potential integration into the operational pipeline and possibility to distribute it to NDCs. So if you are interested to know more about how the performance of the network can be affected by changes like station failure or installation and certification of new stations, you are welcome to join my board number 22. Thank you.
Morning, everybody. I'm Shaban Laban, lead processing engineer. I'm working for IDC, automatic processing section. Today, we will talk about CLF miner. It's a new and efficient and fast approach for temporal stream mining, especially when you are working with the continuous data process. It's very hard to use traditional time intervals to monitor and evaluate the continuous data process. So we are modeling, using a modeling approach. We are shifting the program from time domain to state domain. We feed it the continuous CLF records into the expert system. Then we infer it. We get many patterns that we can discover many anomalies and discover hidden madness in the continuous data process. Also, we can map again this data, these events to our real scenarios. We can get more information. We can produce the results in 10 minutes interval, 1 hour daily and monthly. We are able to generate many performance indicator metrics like timeliness, data availability, distribution process indicator, and other things, as well as exploring it with different things. Please come by and see more in board 23. Thank you.
Good morning. My name is Rizkita. I'm working also in the CTBTO in the IDC Ops MFO. In Ops Center, data quality monitoring is the main control, the mechanism that we are dealing with the incident or the potential problem at the station to maintain the IMS network performance. So the question is always, how does PTS, in this particularly is Ops, address the needs to improve the data quality monitoring and optimize the use along with another existing PTS monitoring tools? The answer if there was a dedicated platform or the portal was developed along with the other PTS monitoring tools, and this portal was the developers as the result of the cross-divisional collaboration in PTS to support any technical needs by internal staff. The result after implementing this approach over the last 3 to 4 years, show the significant improvement in the Ops Center when dealing with the data quality issue. Please visit my poster for more information on how Ops implement this in our daily tasks and some use case, the real use case that we deal with the station operator. Thank you.
Good morning, everybody. My name is Yassin. I'm working in the IMS division, engineering and development section. And this poster is about the schedule calibration of IMS seismic, hydroacoustic, T-phase, and infrasound stations. So this is a process that is performed on a yearly basis for this different type of technologies. In my e-poster, you could see the different methods used for seismic and infrasound. There would be some historical results that would be also available, and also how the process works and what are the current challenges is something that I'll be happy to discuss if you come to meet me. And this is a second poster. This one is about the failure analysis of IMS stations. So basically in this e-poster, there would be the discussion on how the computation of station downtime is made, and based from that is how the issues are categorized and which kind of actions are taken to recover from the station and to plan for a better robustness to stations downtime. So if you're interested, I'd be happy also to discuss this topic with you.
Good morning. Good morning. My name is Fernando, and my poster is about a paradigm change in telecommunications, which may be applicable to GCI. I'll be happy to see you at SnT2023.
Recent advancements in satellite technology have led to the increased deployment of broadband and low-latency services in areas where terrestrial connectivity infrastructure is not available. The International Monitoring System station operators' experience and the Commission field activities could be improved by leveraging new connectivity options, improving data transmission. Low Earth orbit connectivity could be deployed to provide service in geographical regions with no standard geostationary satellite coverage or mobile data connections. Low Earth orbit connectivity could be provisioned in upcoming OSI integrated field exercises and in future deployments of new monitoring stations and upgrades on existing ones. What integration challenges would be present in this project? Are the processes of installation, training, and maintenance optimized when using this type of connectivity? Can the global communications infrastructure be enhanced with these options? Recent advancements in satellite technology have led to the increased deployment of broadband and low-latency services in areas where terrestrial connectivity infrastructure is not available. The International Monitoring System station operators' experience and the Commission field activities could be improved by leveraging new connectivity options, improving data transmission. Low Earth orbit connectivity could be deployed to provide service in geographical regions with no standard geostationary satellite.
Good morning, Daja Hao. My name is Abayomi Gaius Oshotui, and I'm having a presentation on a new method of seismometer orientation correction via amplitude and energy-based teleseismic receivers function measurements. Basically what we did is to test different approaches, including the amplitude-based and the energy-based methods using the receivers function method to correct seismic station misorientation. And that method was tested in the western part of Africa, and we try to constrain the method towards inland stations, coastal stations, and island stations, so as to know the sensitivity of our methods in these different geological terrain. And also we tested different Gaussian parameters on the receiver's function to be able to know the effect of the complexity or the simplicity of the underlying geologic structures. In the course of our study, we tried to implement the corrections on receiver's function waveform, and as we can have it on the slide there, we saw that for some stations that are well oriented, the corrected stations and the raw station, the corrected receiver's function and the raw receiver's function have a very near perfect fit. Meanwhile, the not well oriented stations have some forms of phase shifts and amplitude variations. And also we tested a correction on receiver's function ZH ratio, and we saw that the error bars were very, very significantly reduced, so which shows that our methods quite work well. And also we did some forms of correlation of the amplitude method and the energy-based method, and we can see very clearly the effect of heterogeneities from each of the approaches that we used. And I want to welcome you to SnT20 in the Wintergarten to attend my e-poster presentation so that we can interact better. Thank you very much.
Hello, my name is Casey Adderhold from EarthScope Consortium. I'm here presenting on behalf of Bob Woodward. We contributed to the collaborative SNECA project, or Seismic Network Expansion, in the Caucasus and Central Asia. This project utilized a common design across all 6 participating countries. This design was informed by the successful deployment and operation of the Transportable Array project funded by the National Science Foundation, but particularly the station design used in Alaska and Western Canada. This used a broadband seismometer, shallow post hole with above ground infrastructure, modest to house the electronics. While significant changes were made to the construction plan due to the pandemic, the in-country teams have successfully deployed a majority of the stations, which are now reporting in real time to the EarthScope data archive, which is public. If you'd like more information, please come to poster 31. Thank you.
Good morning, ladies and gentlemen. My name is Yang Qing from China. Today I will do the brief introduction about portable flexible solar charging pack for OSI. Everybody knows in the practical scenarios, there will be no electricity supply, but most of the mission critical or health and safety equipment would rely on electricity power. Portable flexible solar cell is a new type of energy material in the world. It has small size and high power capacity. So that the 3 solar charging cell could be connected to a single solar charging pack. The portable flexible solar charging pack has many characteristics. For example, lightweight, work with sunlight, and tool-free installation, and can be support multiple environment, and so on. Thank you very much.
Hello everyone, my name is Maxime Griandini. I'm a project engineer from the French company EnviroEarth. In our presentation, we describe a backup cellular intra-site communication system for infrasound monitoring station. This system the purpose of this system is to provide a backup line in case of the main communication system outage or failure. We have installed and tested this system in real condition on site at one of the infrasound monitoring station IS-11 in Capo Verde. And we have, in our presentation, we present some results that we have obtained during the testing phase. So if you are interested to know more, please come see poster number 33. Thank you.
Thank you. Okay, good morning, everyone. My name is Sam Toom, and I'm from the on-site inspection division at CTBTO. And my talk about the power generation and distribution systems at the base of operations during an on-site inspection. So the poster will show the various systems we have in place, so an uninterruptible power supply and hybrid power unit that can integrate solar power into the system and provide a good, stable power supply for the inspection, because without a stable power supply, the inspection will fail. So we need to make sure we can sustain the power for them. Okay, if you want to know more, it's poster number 34. Okay, thank you.
Okay, good morning. My name is Tiawan. I'm from Indonesia. I'm going to talk about the batteries configuration and why it is replaced with the new technology, because we have to cope some of the problems regarding the old batteries technology. And then also I want to talk about the new battery technology, the lithium iron phosphate. It's more reliable. We can also talk about the price. We can compare about the price. And also I want to discuss about hybrid solar change controller. So not all of the stations are using the AC power. Sometimes we have DC power, not all the stations using DC power on the solar panel. We can also use the AC power, so we can combine. So we will reduce downtime because of the power. And then I want to discuss also about the proper tools we can use to maintain battery's life. If you interested in my poster, you can see my poster at booth 36, I think. Thank you.
Hello, good morning. My name is Gregory Bren with the Engineering and Development section of the IMS. As part of our work, we're exploring new battery technologies to be deployed in extreme polar environments. So this poster presents preliminary observations of charge and discharge characteristics of the lithium iron yttrium phosphate batteries at cold temperatures from 5C down to negative 15C. This poster will also present preliminary temperature and solar charge controller observations from PS35 and Peludui in the Russian Federation to better understand the power system design, especially through the cold winter months in 2022 and 2023. So if you're interested in learning a little bit more about some of these battery tests and some observations from PS35, come visit my poster at number 37. Thanks.
Good morning. I'm John Christensen from Norsar. I'm managing our NDC, and our poster will show the battery upgrade that we've done at the Norsar seismic array, auxiliary seismic array at Spitsbergen. The poster will go through the different design choices made to operate this off-grid array in an Arctic environment. And it has been now in operation for more than a year, so we have some preliminary results as well. So if you are interested in a fully compatible off-grid power system in the Arctic, please visit my poster on board 38.
Good morning, dear colleagues. I'm Li Peng from Hope Investment of China. Technology development means opportunities, and this will also push forward the development of the verification regime. So the commercial micro and nano satellite technology actually means more opportunities, especially in not only a single country will dominate this technology. So more people, more countries and organizations will have the technology, and then we can utilize that in a more transparent and feasible and secured way. So our presentation is actually will provide micro and nano satellite based IoT service solution. This will give opportunities for the organization to have management of the OISS samples, the management of the IMS stations, and also for the security and health of the inspectors. Please come to visit our poster at board 42. Thank you.
Good morning, I'm Ben Hamlet from Sandia National Laboratories. I work on the Geophysical Monitoring System project, or GMS, which is the next generation waveform analysis and processing software for the US NDC. And we also release it regularly open source. My poster goes through some of the concepts behind the data access components in the system, including its data model and the data access interfaces. And it also describes one implementation of those interfaces called the Legacy Data Bridge, which allows the GMS user interfaces to access data from the legacy system. So I'd be happy to talk to you about this some more. Thank you.
Good morning again. I'm Shaban Laban, Lead Processing Engineer, International Data Center, Automatic Processing Section. Today we are introducing a workflow as a service. We are intensively using workflows to monitor the complex and distributed processes inside IDC. This workflow is the old one, is the legacy, is Linux-based and very hard to configure, and you need continuously to connect to databases. We have, I did again in 2005, another one with Java-based. It was working fine, web-based oriented, but many browsers did not support Java anymore for security reasons. We have now using HTML5 response and JavaScript to make a workflow as a service. So this means that you can do many templates. You can use it in your mobile phone or any other web application, any other desktop application, computers. We can use it also reusable. You can use it, you can embed the component into your dashboard, and it will work effectively without anything. You can use many widgets in the same window, and it will not affect. We will try in future, we will add more templates, we will add more widgets, new widgets. And if you want to know more, please come by and see me in board 51. Thank you.
Good morning. I'm Gordon McLeod. I'm not Jonathan McCarthy. And we're both from Los Alamos National Lab. Basically, we have a vision of having the NDC in a box in the cloud and being able to do the analysis in the cloud much faster than you can do with the normal CBS capacity building systems that are currently going out. We've been testing it with different NDCs and with ourselves, and we just want to report on the progress and have the discussion of the vision of being able to better utilize the data and do the analysis faster. So, thank you. And we're in, it's poster 55, and Jonathan will actually be on the virtual session this evening.
Good afternoon, everyone. Let me introduce myself. My name is Sezim Sonim Abushawa. I am from Kyrgyzstan, and during the years of nuclear testing network of seismic station of the Institute of Seismology of National Academy of Science of Kyrgyz Republic has operated the territory of Kyrgyzstan. The data which is a great value research in the seismic monitoring area. Most of the stations were installed for nature and agreements, search of seismic noise and the bedrock and especially equating standards. In addition, most of the nuclear test in Central Asia test sites of Simpolat in Kazakhstan and Alopnor is as well possible nuclear explanation on the territory of the users were carried at regional of destination of Kazakhstan network. In addition, powerful checkful explanation were carried of Central Asia for industrial and research reports. This parameter for such explanation are with good actually seismograms and explanation earthquake records by seismic station Kyrgyzstan can be used by various tasks and seismology, especially of the parameters historical seismic event, studying the dynamic processing in Central Asia and the South, regional time, resource record gauge, historical of the seismographs NASCAR condition number, what relate to seismograms in scanning metadata. Is historical seismograms, these bulletins, the corresponding to the Cretan age. Thank you. Thank you.
Good morning, everybody. I am Rambulamana Namamiarzo from Madagascar, NDC. On this topic, I talk about the system developed by our NDC team. The objective is to minimize downtime during an eventual outage. The system uses a Raspberry Pi and a SMS module. In case of an outage, it sends a SMS to alert the local operator and the team. And after fixing the problem, another one is sent to the local operator and the team. So, come to see my e-poster. Thank you.
No slide? Yeah. Okay, no slide. Good morning. Sorry, there is no slide, but it's a couple of bullet points. My name is Adriana Molero. I'm from Managing Director from Ads Project, and this work has been done by my colleague, Juri Starovoit, from Ads Project as well, in cooperation with my ED colleagues from IMS. So this is about the revalidation process of the IMS station, which is undertaken every time a change is done at the station which significantly affects the detection capability, the data availability, or the system response. The process is led by ED in cooperation with IDC, with the station operators, and usually with contractors to do the civil work. The process is done in 2 steps usually. First, the infrastructure and the civil works, and then the equipment installation, the equipment replacement. And the end goal of the revalidation, so once the revalidation process and the equipment is being installed, is to assure the compliance with the technical requirements of the stations as per the IMS operational manual. And to do so, there are a number of tests done with the software and the hardware at the station, so to assure the compliance with the requirements. If you want to know more, we are at the number 27 screen, and that will be it. Thanks for your attention.
Good day. Our poster is called Study of Historical Peaceful Nuclear Explosion Parameters Conducted on the USSR Territory. The archived data of KNDC were used for the work. The seismological bulletin for 1980 peaceful nuclear explosion conducted on the USSR territory was created. Magnitudes and energy classes were calculated. The materials were used for the construction of regional travel time curves and calculation of magnitude and energy classes dependence on the explosion yield. Collected, systematized, processed data on the peaceful nuclear explosion can serve as a database of reference events for its application as calibration sources. In addition, the created bulletin can be used for detection and determination of nuclear tests within the CTBTO. If you want to learn more about this, come see my year poster during session P2.5. Thank you for your attention.
Hello everyone, I want to introduce you my poster, Analysis of Different Nature Events, Records from the Semipalatinate Test Site region. The work presents records of underground nuclear explosions conducted at Digilen experimental field at the Semipalatinate Test Site. The digitized historical seismograms were compared with digital records of events for Semipalatinate Test Site having different nature. The database of digitized seismograms of underground nuclear explosions was created. The archive records of underground nuclear explosions allowed for determining dynamic characteristic of different wave types and calculating magnitude and energy classes. If you want to learn more about this, come see my e-poster during session P2.5. Thank you for attention.
For most important cases within CTBT verification infrastructure, such as IMS data gathered at internationally distributed IM station and transmitted through GCI to IDC Vienna, there is a need to make standing arrangement to prevent data from being eavesdropped or intercepted. Link encryptor, IP encryptor, radio encryptor can provide protection for digital data transmission on translines, IP communications, HF, VHF, UHF radios, voice, and data communication. By these encryptors, various cross-border and interregional data of CTBT can be protected, including various channel data. Even if the data is intercepted by a third party, the data content cannot be obtained. We would like to offer demonstration and testing allowing for deep communication of application scenarios and the CTBT requirement.
This work describes our ongoing pursuit of a goal to use newly acquired GPU resources to enhance the performance of the FlexPart atmospheric transport model. So far, it's been very challenging for two primary reasons. One, FlexPart is a 25-year-old legacy code with a complex structure and a large number of global variables defined in Fortran modules. It's nowhere near a textbook example for successful GPU implementations. And also, the NVIDIA Fortran compiler has exhibited bugs that manifest themselves in hard-to-detect ways. And although NVIDIA has been responsive, finding these problems has taken a lot of time and effort. So at this point, we've finally managed to compile and execute FlexPart in an open ACC environment, but verification of performance and integrity of output still needs to be performed, and we don't anticipate a smooth path.
So with this, we conclude our session of lightning talks. The next session will start at 11. For those who had their talks now, you can find your slides as of 11 on the screens in this room right here. And I would like to invite the speakers for the next session to already come to this corner so we can start lighting you up. Thank you very much.
Good morning, welcome. In a minute, we're going to start with the last e-poster lightning session of this morning. Welcome.
Okay.
But you get out that way.
Okay. So, that's not mine. 4, 6, 7. Yeah, perfect. Thank you. Good morning. I'm Rolf Häfner from Sonicona. We are located in Germany. We were contracted by the CTBTO to develop a method for the continuation period of the OSI called resonant seismometry. The task was split into 2 parts. Our job was to analyze earthquake data. We developed a toolbox of methods combining onset delay variations, spectral variations, and automated mapping methods for using earthquake data from seismic arrays to locate the cavity of the underground nuclear explosion Tiny Tot here at a Nevada test site. I think we are quite successful. We detected an anomaly at the site and also a variation of different geological phenomena. So please feel free to come to the poster and discuss it. Thank you very much.
Did you turn it off? Is it on? It's on. Good morning, everyone. I'm Henrik from FOI in Sweden. If you see something you like here, you should definitely check out my poster tomorrow. I will talk about sample containers equipped with RFID tags and also the multi-sample inlet module for sauna field. Thank you. No, it's fine.
We'll just check that they put the slide. You can go ahead.
Thanks.
Hello, my name is Nick, and I want to present you our invention. It's a Xenon generator. What's the main task? The main task is Xenon cluster systems must be calibrated for all 4 Xenon isotopes. But nowadays, in case of short half-life time of Xenon 135 and small activity of Xenon 133M in spikes, it's not possible to properly calibrate it, which affect for problems like false positive events, false alerts, and etc. And our generator, it's possible to produce the Xenon with activity up to 1 kilobecquerel just in 10 days. It's portable, it's safety, and can be delivered in every point of world. It means that in every spikes, it's guaranteed with known activity, known concentration of all 4 Xenon isotopes. And that's all. That's the main idea.
Hello, my name is Andrei Vlasenko. I represent company Baltic Scientific Instruments from Latvia, Riga. Maybe you know us as a detector manufacturer, particular high purity germanium detectors, silicon alpha detectors, but we produce monitors for environmental radiation monitoring as well. So we have system that includes all types of environmental monitoring. For example, radioactive aerosol monitor, iodine monitor, mobile monitor, monitor for aquatic environments, and also dosimeters. All monitors are manufactured in a modern state-of-art style with newest element base, newest detector, in particular strontium iodine. So if you want to know more about our monitors, please ask me tomorrow at my poster session. Thank you.
Hello everyone, I'm Célian Courtney from CEA France, and I'm going to talk to you about the silver exchange zeolites, which are the absorbent materials that we use in the SPELX-NG process, which are the best materials that we can use at the moment. And the next optimization step in the SPELX-NG would be to use them everywhere in the process instead of the activated charcoals that are used in the purification step. The problem is that as of this day, there are many issues about the stability of the SPELX, of the silver exchange materials due to deactivation processes in the temperature cycles and the exposition to chlorated compounds. And on top of that, when using ZSM5 zeolites, we have differences in between ZSM5 from the same suppliers. So if you're interested in the relationship between structure, absorption capacity, and stabilities of the materials that we use in the SPELX-NG process, be sure to come and check out the poster. Thank you very much.
Thank you. Hi, folks. I'm Harry Miley from Pacific Northwest, and I'm giving a poster on what we call RASA 2.0. RASA is a device which you see on the left, which we began at P&L in 1992 and tech transferred in 1998. And somebody named Matthias Auer had an idea for a future version of this, and we've finally gotten around to starting. So we will talk about the progress towards transforming the RASA into an electrostatic device that can make more frequent measurements and give faster data and better location. So I believe this is at board 15. So come have a chat. And also see Michael Swanwick's poster about how he did the electrostatics. Thank you.
Good morning. My name is Matthew Goodwin. I work at the UK CTBTO Radionuclide Laboratory, GBL 15. This poster is talking about trying to make noble gas detectors more sensitive in the laboratory setting. It's long been known that particulate IMS measurements can be improved upon in the laboratory, but we haven't always had the same approach for noble gas. I believe that the laboratories can improve upon some IMS measurements, which will help us during event analysis, expert technical analysis, that sort of thing. So come to the poster, and happy to talk to you about that. Thank you.
Thanks. I'm Michael Fox from PNNL, and my poster is on the development of a modernization and sustainment effort for USL 16 for the noble gas capability. We have a lab that measures radioxenon, but the system was developed about 10 years ago, and so we're working on upgrades that we can implement that kind of mimic what the next generation of radioxenon systems have in the IMS. And so you can see on the right-hand side, we're well underway with pulling in some of those technologies, and you can come to my poster at 19 to hear more about the upgrades we've implemented. Thanks.
Hello. This is actually a follow-up to a silicon beta cell radioxenon detector. You can see the diagram there in the upper right and a picture of the detector itself. We've managed to make some improvements in the threshold of the detector and the resolution using a SIPM-based well detector for the gamma portion of the beta-gamma detection, as well as some hardware changes to the high voltage supply and cabling. With that, we've been able to drop the threshold from 45 keV to less than 22 keV, making additional low energy X-rays and conversion electrons available for detection. Thank you.
Good morning. We will present some concept and methodology for the handover of the sample during an on-site inspection. So the chain of custody plays a fundamental role in ensuring the forensic value of the analysis and of the environmental sampling and the analysis at the lab. And it includes several steps, including the physical presence of the sample somewhere, the physical possession of the sample by the inspectors, and also all the metadata. So we are trying to figure out how we can apply all these all these steps in the procedures. And one solution can be to use the blockchain methodology that included several control processes during the possession of the sample, including timestamp and including the need to check for all the people involved in the possession of the sample to ensure that the process is going right. So I will wait at my poster session. Thank you.
Hello, I'm Katarina Söderström from FOI, Sweden. Our poster will be presenting our Xenon lab system that we have been running for many years at our place. Especially we will be presenting the results from the PTE measurements that we've been taking part of, and also remeasurements of our samples from our IMS system. So please welcome to board 22. Will you find me? Thank you.
Good morning, everyone. My name is Sapida Azimi. I'm about finishing my PhD. This is not mine. Sorry. In our work, we developed a new radio xenon detection system based on beta-gamma coincidence using a sodium iodide detector and a PIPS detector due to lowered memory effect and better energy resolution compared to a scintillation detector, and we employed a holmium source for energy calibration and performance check of the PIPS detector. I would like to invite you to have a look on my research on board 23. Thank you.
Good morning, everyone. I'm Christine Johnson from Pacific Northwest National Lab, and we've developed and deployed a gas sampling system to automatically collect, do some analysis, and circulate gas samples from a variety of underground boreholes. We've also been developing a flow-through radio xenon detector using a carbon fiber gas cell to allow for use of the lower energy gamma rays. If you'd like to learn more, please come by my poster. Thank you.
Hi everyone, my name's Ayrton. I work at the UK's radionuclide laboratory, GBL15, at AWE in Aldermaston. So my poster gives an overview of some advanced spectroscopy techniques currently in use and being developed in support of nuclear explosion monitoring. These include gamma-gamma coincidence spectroscopy for particulate samples, which have been shown to drastically reduce the signal-to-noise ratio, as you can see on a plot there on the left for some work done at AWE a few years ago. And on the right there is an image of a detector setup that was used to improve the efficiency of a high-resolution beta-gamma system for radio xenon measurements. So if you want to know more about this, then come see my poster tomorrow morning. Thank you very much.
Hello, I'm Michael Swanwick from Creare, which is an R&D company in Hanover, New Hampshire in the United States.
We're working on electrostatic precipitation for radionuclide particle collection to be integrated into RASA 2.0. RASA 1.0 has an impact filter. We're replacing that impact filter with an ESP. We have built a full-scale prototype system. Our experimental data has shown collection efficiencies well over the CTBT 80% collection efficiency requirement. Some system highlights: we use flexible webs. We're compatible with dual or coincidence detectors. We can have well over 1 year's worth of samples on our system at a time. We're fairly compact. Currently, we're working on sample packaging and handler to integrate into those dual detectors. That's work with PNNL right now. So our next steps, we are, in the next couple of months, going to start a program to ruggedize this and put it out in a shed and test it for long amounts of time. So please let me know if you have any questions, and I'll be at the poster tomorrow morning. Thank you.
Hi everyone, I'm Lindsay. I work at the Swedish Defense Research Agency. We have a great poster about the Sana Cube Array that we have installed in Sweden. It's been up and running for about 2 years, and we will share our experience so far. So I will be at screen 32 tomorrow morning. See you there. Thank you.
Hello, good morning everyone. I am Christophe Gueb from the Belgian Nuclear Research Center. And in this poster we are looking at the collection and purification of xenon from air in different porous materials. So more specifically, we looked with my co-authors to the use of silver exchange zeolites and metallic organic frameworks, which are porous materials, to collect and separate xenon from atmospheric air and directly from atmospheric air. So what we want to avoid any pre-purification of the gas stream before processing it. With the aim to potentially simplify or reduce the power consumption of IMS noble gas systems. So we want to answer two questions. The first one is how much xenon we can collect on the material and how selective the material is for xenon compared to other gas components, and then how much xenon we can recover thermally and how pure we can get the xenon. So if you want to have an answer to these questions, I invite you to our poster 33. Thank you.
Good morning, I'm Marty Kyler from Pacific Northwest National Laboratory in Washington State, USA. This research is in progress. You have seen a couple of brief talks already this morning about large volume electrostatic precipitation-based aerosol collectors. This research is looking at developing a small, portable, low-power radioaerosol monitor system that will rely on ESP for the aerosol collection and have onboard radiation monitoring detectors. So if you're interested, stop by the poster in the session tomorrow morning at 9 a.m. Thank you.
My name is Jim Hayes, Pacific Northwest National Laboratory, and over the last many years, we've developed the Xenon International system. It's gone through extensive testing. Recently, it went through 6 months of testing at Teledyne Brown Engineering, and then 6 months of testing at Shaunsland for acceptance into the PTS as a qualified system. My poster is about the experiences and some of the detects that we saw, especially some of the anomalies that we saw. So if you're interested in learning about the detects, the anomalies, or anything else about Xenon International, please stop by, and happy to talk with you. Thank you.
Dear colleagues, my name is Roman Alexandrov.
and Duhov's Automatics Research Institute. I present to you a report entitled Obtaining Enriched Argon from an Air Mixture by Pressure Swing Adsorption Method. The work presents results of the development and experimental investigations of the sampling unit of the automated system for monitoring the 37 organ content in the soil and surface atmosphere. The adsorption and separation characteristics of various sorbents for air separation and argon extraction from air samples using volumetric method have been studied. The adsorption isotherms of the main air components, argon, nitrogen, oxygen, at room temperature on the sorbents in the pressure range from 0 to 10 bar were obtained. Based on the study, a two-stage system of pressure swing adsorption, PSA, was created to obtain enriched argon. Thank you.
Hello, my name is Chushiro Yonezawa. I'm from JIIA of Japan. More reliable evaluated decay data are available for the CTBT-delivered radionuclides than those used for the selection about 20 years ago. I prepared 5 tables for radioactivity measurement from evaluated decay data of the DDEP, NSDF, IAEA, and other publications. The maximum relative difference between the compiled data and the data used for the selection of the CTBT-delivered radionuclides were 10% for half-life, 36% gamma ray intensity, and 0.1% gamma ray energy. Since half-life and gamma ray intensity affect directly to accuracy of the analysis result, using of this compiled data is strongly recommended.
Hello, everybody. My name is Nick Sidorov. I'm from VNIA, Moscow, and I'd like to tell you a few words about my e-poster. The radio-xenon system gain stability is critical to provide accurate measurements of the activity. There are several different methods for processing daily quality control, beta-gamma two-dimensional spectra for checking energy calibration. Fitting to template seems the most correct method for monitoring the calibration stability. The possibility of using a template for a two-dimensional spectrum has been investigated. The template is created using locally weighted scatter plot smoothing of the two-dimensional long QC spectrum. It's necessary to smooth out the long QC spectrum histogram, and daily fitting of the template to the QC spectrum using the weighted least square method gives the tweaking factors of the gain shift. A number of calculations have been carried out based on the results of measurement of Russian system mix QC source, cesium and barium. Different approaches have been compared, and the template fitting method provides the most stable results even with poor statistics. I would like to invite you to see my poster. Thank you very much.
Hello everyone, my name is Sara Azim Khani. My poster is about identical mother and daughter radionuclides related to CTBT. In this regard, the ratio of daughter nuclei to mother nuclei was calculated for two scenarios. such as lanthanum to barium. Finally, the zero time of a nuclear event was estimated. Thank you so much.
Hi everybody, my name is Kobe and I'm presenting a new idea for grouping of particles. As you can see on the slide, we have the basic idea of grouping. We also show an experimental system and we base on the CFD simulation. The CFD simulation shows that it's possible to take particles into groups and those groups can be easily monitoring and filterized. So basically, this idea can lower the detection limit of any particular system monitoring. If you would like to hear more, please visit me on my poster. Thank you.
Good morning. My name is Rose Perea, and I'm with Pacific Northwest National Laboratory. My work is on the long-term background measurements of radio xenon beta gamma detection systems. We are interested in the influence of the, we are interested in the environmental effects on these background measurements and what their influence on minimum detectable activity calculations will be. If you're interested in learning more, my poster is number 34 and it's in section P3.6. Thank you.
Hello again. Matthew Goodwin, this time from the UK National Data Centre. This piece of work is looking at reconstructing radio xenon sources, which is not an easy thing to do because of the background problem. The background problem is persistent, and we need to identify the signals of interest within that background. We then need to look at how we associate those signals with other signals or non-detections as well, and then how we put all of that information together with some ATM into a Bayesian inference tool known as FREER. You'll have heard Ian Hoffman talking about that just yesterday. So I'd be happy to talk to you more about this work. Thank you.
Hello everyone again. My second presentation poster, some detection system of radio xenon like the Russian mix system create a two-dimensional beta gamma coincidence energy spectra using plastics insulator cell and to detect conversion electrons and betas and sodium iodide crystal to detect gamma and X-ray. These beta gamma spectra are used to estimate activity of the radio xenon isotopes in the air. Some approaches to estimating the activity using beta gamma spectra are, for example, net count calculation method and matrix methods and maybe standard spectrum method. And within these approaches, algorithms differ in many ways and can provide different estimates of the activity. A comparison of different methods and algorithms have been carried out in this study. Activity calculations using different methods were performed and the results were compared. Evaluations have been made using real data from the mix system. We recommend using method with ROI as a regional of interest since they are much more resistant to perturbation. Matrix methods are very convenient for calculating errors and uncertainties and MDC, and the Bayesian approach allows us to use a priori knowledge about the background activities of isotopes, which potentially provides the best results. I'd like to invite you to my poster. Thank you very much.
Good morning, my name is Yuichi Kijima. I have 3 posters. This is the first one. This is about the investigation on how SRS, so receptor sensitivity fields, can be used for identifying samples that may have received radioactivity from the same release event as the level 5 samples. Since the analysis of spectra at IMS radionuclide laboratories might influence the reliability of analysis results, it is proposed to investigate a method that can be used to identify potentially associated samples at the same or neighboring stations that may have received radioactivity from the same release event as the level 5 samples. Therefore, we investigate the method to associate the level 5 samples. Thank you. So next one, please. This one is about the investigation on sample association using decay consistency analysis for consecutive level C samples and priori and post-level B samples. The standard screened radionuclide event bulletin, SSREB, which is one of the IDC products, needs to be influenced by associating the detections of CTBT relevant nuclides with other samples that detect the same release. In case of detection of multiple isotopes, the consistency of the isotopic ratios in subsequent samples with radioactive decay gives another positive hint that the isotopes contained in the different samples comes from the same source. ATM can also provide further evidence for more confident sample association. So, next, please. This is about isotopic ratio distributions of radioxenon at IMS radionuclide stations using emissions from nuclear facilities with decay correction based on the atmospheric transport time distributions between these facilities and the stations. The typical isotopic ratios of radioxenon released from nuclear facilities are well known. However, due to the short half-life of some of the relevant radioxenons, the isotopic ratios have changed when reaching the IMS radionuclide stations. Therefore, we are investigated on the isotopic ratio distributions, also activity concentration distributions at IMS radionuclide stations. This is for example, the development of the expert technical analysis, ETA, and also the development of the xenon background estimation tool, Kisibet. That's all, thank you.
Thank you. Okay, so for the purpose of this talk, I am Brian Schramm today. Brian couldn't be here, so I'm going to fudge my way through his lightning talk and his poster number 50, I believe. Anyway, we have a vision for a future pipeline, which is the orange one in the, below, and the blue one up above is the pipeline of today. It's been exciting to be at this meeting to see that many people have bits and pieces that fill in throughout this vision. So we feel like there's a lot of progress. I will be reporting Brian's progress in those various squares that are shown there. Thank you.
Good morning, my name is Hakim Gadou from CTBTO. The poster is about a new Monte Carlo simulation software, GrandSim, which is based on GANT4. It is designed to handle all high-purity germanium in use at IMS stations for particulates, but also noble gas in phase 2, beta-gamma detectors. The software is not only open source, but it is also implemented to allow more automation and to demonstrate more performance in terms of running time, but also interaction with the environment. The software is now deployed in the IDC, and it is also delivered to national data centers. Thank you.
Good morning, I'm Matthias Auer from Instrumental Software Technologies, in short ISTI. I give a presentation on the STAX data viewing software. STAX stands for Source Term Analysis of Xenon, It's an experimental network to measure releases from isotope production facilities, like medical isotope production or nuclear power plants also. And the data can be used to better interpret the data at IMS stations, to better understand background and distinguish from anomalous events. That presentation is actually on the software that processes and analyzes data, and we also developed a web-based interface to view the data, so you can view time series of concentrations or isotopic ratios, and also time series of simulated concentration at IMS stations. In addition to the poster, you could also get a hands-on demonstration if you like at the ISTI booth downstairs. You can visit me to test out the software, and the poster is at screen 54 tomorrow morning. Thank you.
Okay, hello, good morning. Yeah, again, this poster is about the characterization of CTBT relevant radionuclide events. So, yeah, for the measurement at the IMS station, we get the result of concentration. It's not the final step. It's just the start point for the event analysis. So we are working on a project to develop a new software from the concentration estimation, estimated concentration in the sample measurement until the event calculation, like the event discrimination and the event zero time estimation. So in this software, we will include the release scenario module and also the isotope ratio calculation by different methods. For example, normally we have the nominal value, that's the ratio of two concentrations. When the denominator has a large uncertainty, we need to use the second order polynomial, and we can also make the estimation by using Monte Carlo calculation. So for more detail, please come to the poster. Next slide first. Okay, now this one is about the calibration. Here I already show for the next generation noble gas system, we have different systems, like Spalax NG from France, like the Solar 3 from Sweden, and the Xenon International from the American. For each system, they have their own specific calibration procedure. Now, from the IDC side, we try to make a unified calibration procedure. The one point is to estimate the gamma efficiency of 30 kV by using the Xenon 131 metastable. With the 4-pi geometry, we can estimate the efficiency absolutely and then transfer to other isotopes. Yeah. For more detail, please come by our poster. Thank you.
So the poster is about reanalyzing the 1 year of data to 2014, which is used by the community as a baseline when it comes to comparing simulations to observations. We took advantage of the recent enhancements in the software, Autostrada, including the BGM module, and we reprocessed 13 sauna systems for the whole year. The high level of the results clearly show significant reduction in the rate of false positives for the two metastables and Xenon 135. This is only one of the plot for one of the 13 stations. If you want to see more, please visit our poster. Thank you.
Good morning, my name is Hugues Paradis. This poster is about our work on the development of a new method of analysis for two-dimension beta-gamma coincidence spectrum. This method is based on the Bayes formula and is automatic without expert analysis. That's all. Please come to see our poster. Thank you.
So, good morning, everyone. The Radiometry Laboratory of DNA Research Center in Italy developed a new methodology relating the lowering the high purity germanium background measurement. The main goal of our work is correctly evaluate the value and the trend of the environmental background of radioxenon in our country, so in Italy, in order to detect anomalous contamination in case of a possible nuclear accident. But due to the low concentration of radioactive noble gas in the atmosphere, especially in Italy, our efforts have been directed mostly at the reduction of the MDA of our measurement system, trying to improve the sensitivity and reduce the background noise. Thank you very much. Okay, thank you.
Distinguished colleagues, good morning to everyone. My name is Giuseppe Ottaviano. I am a research physicist at ENEA, the Italian National Agency for New Technologies, Energy and Sustainable Economic Development, Bologna Research Center. This work has the following objectives. Propose statistical methods to be useful to NDCs to investigate radioxenon background and radioxenon anomalous values. Propose a statistical parametric approach to both quickly identify large variations and specific patterns in radioxenon background and anomalous values. Propose a statistical non-parametric approach to identify variation in both the mean value and the variance, strengthened by the calculation of a p-value. Propose to integrate the interquartile method used by the ADC. If you want to learn more about my poster, please come see my poster during the session L6 at Wintergarten on the 21st of June. Thank you very much.